Okay, in this segment we're talking about the basics of logarithms. And this is going to include some very basic properties that are associated with logarithms. And they come directly from what the definition of a logarithm is. So you probably recall that we defined a logarithm by using this relationship. You already know how to handle something like this: b raised to the y power is equal to x. But you may or may not recall that that statement is equivalent to this one: log base b of x equals y. Okay, so this is an exponential equation, whereas this is a logarithmic equation, but they are equivalent in nature. Okay, so they say exactly the same thing. And you may or may not recognize that an exponential relationship is an inverse relationship to that of a logarithmic one. They are inverse operations, and one undoes the other one, similar to multiplication and division or addition and subtraction. One of them will undo the other. So we're going to look at some very basic properties that come straight from this definition. The first one we're going to look at is this: log base b, which can be anything, of b is equal to, and this answer is always going to be 1. Because if you think about it, if we look at this logarithmic statement in exponential form, this is saying b to the first power is equal to b. Well, that's of course true. So I can replace these b's with any base I want. I can say log base 2 of 2 is equal to 1. Okay. Or I can say log base 5,000 of 5,000, and that again is equal to 1. Okay. Another very basic property of logarithms is this idea. Log base b of 1 is equal to what? Well, think about this. If we're going to rewrite this as an exponential equation, it would be b to what power is equal to 1? Well, recalling our knowledge of exponents, we know that this has got to be 0, because anything raised to the 0 power is 1. So b raised to the 0 power is 1, or log base b of 1 is going to always be 0. And of course that b can change to anything. All right. So let's think about it in terms of other bases. All right, log. I know this is rough. This is the first video of the morning. The other ones will get better. So how about this one? Log base 2,125 of 1 is equal to, well, of course, that is 0. Okay. Whenever you have a log of 1, whatever that base is irrelevant. The answer is always going to be 0. Okay, or we might just say something as simple as log base 25 of 1. And that, of course, is 0 again. Okay. We also have some other basic properties, and these properties are similar in that they rely on that inverse operation that we were discussing earlier. Okay, so an example of these properties would be something like this. We'll look at them in both forms. Okay, so back to the logarithm basics. We have log base b of b to the x power. And we want to know what that is equal to. And notice that we have a logarithm with the base of b, and we also have an exponential expression with the base of b. And since those are inverse operations, logarithm with the base of b and exponential expression with the base of b, they kind of undo each other, and we are left with just x. Okay. And similarly, if we write it in a different form, we can say b raised to the log base b of x. What is this equal to? And again, we have an exponential expression with the base of b and a logarithmic expression with the base of b, so they undo each other as their inverse operations, and we are left with x. Okay, so an example of this would be something along the lines of, let's do one over here. How about 7 raised to the log base 7 of 20x. Okay, well, since we have an exponent with a base of 7 and a logarithm with a base of 7, those two things undo each other, and we're just left with, what is that exponent? 20x. Or we could think about it in terms of log base 21 of 21 raised to the ABC power. Well, that would give us an answer of ABC, because those bases are the same, and we have an exponential expression as well as a logarithmic expression. They just cancel each other out. Okay, so now let's think of something really fancy and see how something that looks pretty intimidating is not really so intimidating. Let's look at this. Log base pi of pi raised to the square root of pi. Oh, ugly, right? It looks really, really intimidating and complicated, but if we just pick it apart and look at it carefully, we see that this logarithm has a base of pi. This exponential expression has a base of pi, so together they cancel each other out, and we are left solely with the square root of pi. And those are some basic logarithmic properties.